Welcome back. Load balancer. So, a load balancer is a critical component in distributed computing environment that helps distribute incoming network or application traffic across multiple servers. This ensures no single server becomes overwhelmed and improves responsiveness and increases the availability of applications. Let's talk about a scenario where we will need a load balancer. So let's take at this. Let's look at this system. We have the client. The client will send the domain name to a domain name system. The domain name system will send back the IP address. Once the IP address is obtained on the client side, we will try to send an HTTP request to the server, and the server will send back at HTML pages. Maybe the server will connect with the database as well to get some data from the client, for the client, sorry. Let's say that we have multiple clients, and all of these clients trying to send a lot of requests to our server, and our server cannot handle all of this load by itself. So we need to scale. In order to scale, we have two solutions. We can add more resources, okay, and add more RAM, add more CPU, more etc. Maybe we can add more throughput, or we can add more machines, like has S1 for example, and this will be S0. The two solutions have their own pros and cons. The first one, it will be quite simple. Nothing will be changed in the system. We will only improve the performance of the server. But we have some sort of physical limitation to that. We cannot add RAM like endlessly, forever. Also, we cannot add CPU forever. And there's another problem. We have what we can call a single point of failure. What a single point of failure means? A single point of failure means if we add more resources here and we continue adding more resources, we will still working with one server and one server only. And while we are working with one server only, that means when this server has any problem and goes down, we only have one server. So when this server goes down, the full application goes down. So we have a single point of failure here. So how we can solve that? Let me try to remove everything. We can solve that by horizontally scaling, adding more machine. So we have S1, S2, etc. And all the clients will connect, let's say client 1, and let's say that client 2 will try to connect with these servers. And by now, when we have more clients, we add more servers, and we continue to do that, and I guess the application will be always available. And when one server goes down, we still have two other servers that could serve instead of it. But there is another question that comes to our mind: how the client, for example, client 1 will know which server to connect with. The client 1 this client, let's say call this client 0. The client 0 could connect with server 0, and the client 1 could also connect to server 0. And let's assume that one server could only support one client. So if a client 1 and client 0 will connect with server 0, that means the server 0 will be overwhelmed with requests, and server 2 and server 1 doesn't get any requests. And the other thing, let's say that if client, let's talk about another case. If client 1 connected with server 2, and the server 2 saved all the data of client 1 and in the cache, all the sessions, etc. And client 2 will want to send another request again, but how to make sure that client 1, when client 1 trying to send another request, it will always hit server 2, not server 1, not server 0. This where the load balancer comes into play. So let's me first delete everything here to make sure that we will write to the load balancer. Let's take another one. Let's call this one server 0, and we want to duplicate it. Server 1 and server 2. And we have the DB here. Let's delete this as well to make it quite simpler for us. And let's add another shape, and let's take this shape instead and make it white and make it quite bigger, and make inside this white as well. And I will call a load balancer. Let's refer to it as an LB. Yeah. And they try to send a request from the client to the load balancer, and the load balancer here will distribute all the incoming traffic from the clients to the server to make sure that there is no server is overwhelmed with requests, and to make sure also that the cache always remains. So a load balancer is a device or a software application that distribute network or application traffic across multiple servers. And the primary purpose of a load balancer is to ensure that no single servers become overwhelmed, thereby improving overall system performance, availability, and reliability. So the load balancer will distribute all the incoming requests to the server. Oh no, let's make another one here. Okay, this is great. Okay, this is great. So, okay, this is good. So, why we need the load balancer? We said that it's good in distributing the traffic. The first thing is distribute traffic efficiently. So the load balancer prevents any single server from becoming a bottleneck by distributing incoming traffic across multiple servers. Also ensures optimal use of server resources by balancing the load evenly. Additionally, we improve availability and reliability, increase high availability of the application by routing traffic only to healthy servers. Also, we improve fault tolerance, so automatically redirects traffic from failed servers to operation ones, ensure continuous service. So, if server 2 was failed, the load balancer will make is making all the time health checks, will know that server 2 was failed, and it will send requests to server 0 and server 1, and it will not send in requests to server 2. Also, we enhance scalability, so in horizontal scaling allows adding or removing servers as needed to handle varying traffic loads. So we can add more servers like server 3 or server 4 or etc. Um, we also support the load balancer also supports dynamic scaling in cloud environment where servers can be added or removed based on demand. We The load balancer optimize performance, so the load balancer reduce latency by distributing load each sorry by distributing the load, each server handles fewer requests, reducing response time. Also, sometimes not currently all the time, the load balancer handles security like SSL termination and DDoS mitigation. So the load balancer handles offloads SSL and TLS encryption and decryption from backend servers, reducing their load and improving performance. In applications where session persistence is quite important, there are sticky sessions ensure that users session is consistently handled by the same server, which is critical or crucial for applications that rely on session specific. There are multiple algorithms to handle the load balancer and how the handle the load balancer is working. There is round robin, least connection, IP hash, weighted round robin, least response time, etc. We will not talk about them in this video because this is out of the scope. In this video is the goal is to give a high we talk on a high level how the load what is a load balancer and how it works, and yeah. So in conclusion, in conclusion, a load balancer is essential for modern web applications and services to ensure efficient traffic distribution, high availability, scalability, performance optimization, and security by balancing the load across multiple servers. It prevents overloads, enhances user experiences, and provides a robust foundation for handling increasing traffic demands. So that's it for this video, and see you in the future.